In this video, we are going to go over reflections, a type of transformation. So first off, what is a transformation? A transformation is an operation that maps an original figure called a pre-image to a new figure called an image. So a transformation can also change the size, position, or orientation of a figure. And there are 4 types of transformations. There is a translation, reflection, rotation, and dilation. However, in this video, we are just going to go over reflections. So go ahead and pause this if you need to finish writing this down. And then we'll go on to the next slide. Okay, so reflection is the first one we are going to discuss. So a reflection is a flip over a line of reflection. Okay, in each point on the image are the same distance from the line of reflection. So if this is my line of reflection, this point C, say this was, 2 points away, this C would also be then 2 points away. Okay, the X and the Y axis are common lines of reflection. Okay, so normally we'll flip something over the X axis or the Y axis. And reflections result in congruent polygons. Okay, so this shape, when it flips over this line, is still the exact same size, has the same measurements, has the same side lengths. They are congruent, okay? Congruent, same measurement. Okay, so let's look at an example of this. Okay, we need to practice. So graph and label the figure and its image under the given reflection. Give the new coordinates. So like number 1, triangle ABC with vertices at 1, 6, 8, 3, and 4, 2 in the x-axis, okay? So first, we have to plot these points, which I just did. Then we'll go ahead and connect these points here and here. Okay, so I graphed these 3 points right here. Now we are going to reflect it over the x-axis. So remember, this is the x, this is the y-axis. Y. So if I want it to flip over this line, I am just going to merely count how many it is away. So the new C, if it flips over this line, it's still right here on line 4. It's 2 up, so now it's going to be 2 down. So the new number for C is going to be right here. C is going to still be at 1, 2, 3, 4, 4, but negative 2. Let's see, I have B here. B is all the way over at 8 and up 3, but the new B is going to be over 8, now down 3. So 8 is going to be fine, but this is going to be negative 3. B here, put this little guy right here, think of that little 1 or apostrophe as first copy. Okay, that's how you're going to know that one's the copy. A is over here at 1, 6. Well, the new A is still going to be at 1, but it's now going to be down here at negative 6. So right here. A prime or first copy. So still at 1, but negative 6. So drawing the line. Now I can see that this is a mirrored image. This is a reflection of this one. Okay, so it's still going to be the same distance from where I would put a mirror on that line. Look at number 2. So I have a rectangle. Here are the vertices, and then I'm going to go ahead and reflect that over the y-axis. So the first step is I have to plot these points. Okay, so I just plotted those points. We'll draw a line connecting them together to give ourselves the rectangle. And now again, this is the x-axis, this is the y. We are going to reflect over the y-axis. So we're going to reflect right here over that axis. So now J is 1 away. It's up 1, or sorry, over 1, up 1, but now we're just going to go the opposite direction, over and up. Different color. Here. So the new J prime, or J first copy, is at -1, 1. K is going to be, we went over, let's see, 1, 2, 3, 4 over here, positive. So now we're just going to go for negative on that same line. So 1, 2, 3, 4. K, first copy. So -4, 7. Let's look at L. L is 1, 2, 3, 4, 5, 6, 7 away from the line. Now I'm going to go 1, 2, 3, 4, 5, 6, 7. There's going to be my new dot for L's copy. So -7, 6. And last but not least, M. M is 5 away from the line of reflection. So I'm going to go 5 away this way, keeping it at the same point. So 2 right here is going to be M. So that will be at -5, 0. I want you to notice something, okay? So when I reflected over the x-axis, the y value changed. When I reflected over the y-axis, the x value changed. That's it. So now let's flip to the next slide and let's look at the rules for reflecting over the x and the y-axis. Okay, so like we just noticed on the last problem we worked out, there's a pattern for these rules, okay? So when we reflect, okay, let's not use that color. When we reflect over the x-axis, what changes? Well, when I have an x and a y value, the only thing that changes is that x value stays the same. My y value turns negative. So that is the rule for reflecting over the x value. Now, when I reflect over the y-axis, right, so I reflected over the y-axis and highlight that part. My x and y values that I have, the only thing that changes is my x value turns negative and my y stays the same. So that is the rule now that you can apply for reflections over the x and the y value. You can count out the spaces to figure out where the new point would be, or you can just apply the rule for the x and the y reflecting over those axes.